Good day, learners. Welcome to Technical Mathematics lesson. My name is Matule Latakomu, and this lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, grade 11s. Our topic today is trigonometric functions and graphs. So let's look at our lesson objectives. At the end of this lesson, learners must be able to sketch the trigonometric graphs, interpret and analyze the graphs, and understand the following parameters A, K, and Q. So, with trigonometric functions, we have three functions that we have in trigonometry. The first one is the equation of y is equal to a sine k x plus p plus q. And then with the second one, we have the equation of y is equal to a cos into kx plus p plus q. And the third one, we have our equation y is equal to a tan into k plus x plus q plus p and plus q. Then now, all those variables of a, k, p, and q, they have effects on our graphs or our equations there. Okay, so looking at the effect of a, k, p, and q, how does a, k, p, and q affect our graph? So now A will affect our amplitude, it will affect the amplitude of the graph, and K will affect the period of the graph, and P will shift the graph either from left to right or right to left. And now Q will shift our graph upwards and downwards. Correct. So now, looking at the shapes of our graphs, now the first shape that you see here, it represents the graph of sine. It's a normal graph of sine, and that's how you see the shape of the graph of sine when you have A as your positive number. Remember, A is the number or a value in front of sine. So when it's positive, which is greater than 0, that's how you see your shape. Then the second graph that you see there, it represents the graph of cos x. Then that is the shape of the graph of cos. Then the third one there is the shape of our graph of a tangent, correct? And then this one of the tangent, it has also the asymptote. But now we are going to look only for this lesson the effect of A and Q. We're going to look at the effect of A and the effect of Q. Remember, I spoke about the effect of A. We said A affects the amplitude. A affects the amplitude of the graph. And what is the amplitude? The amplitude is the distance from your midline to the turning point. The distance from your midline to the turning point. That is the amplitude, of which it will be your value of A. Then now, the value of Q, we said it shifts the graph up and down. And then we're looking at our midline. If the midline, let's say, is positive, then this graph will go 2 units upwards. Then with the original graph, you can see that the midline is equal to 0. Y is equal to 0. So those are the things that we're looking at. So now, looking at this picture, they say the amplitude is equal to 3. You can see where 3 is positioned. It's positioned where A is supposed to be positioned. Correct? And we agree that the amplitude is 3. You can read from the graph. From 1 to 4, you count 1, 2, 3 units. Hence, your amplitude there is what? Is 3. Okay? And from your midline where y is equal to 0, we can see that our graph has moved 1 unit upward, which now we're talking about the value of q. If it's plus 1, it will go up. If it's negative, then it will go down. So those are the effects that we are going to be looking at today, A and Q. And we're also going to look at the effect of K. The effect of K on our graph, K will affect our period. And now, when we determine the period of a graph or a period of an equation or function that will be given, we have the one for cos, we also have the one for sine. Remember, the cos and sine, when we're saying the period is equal to 360 over k, that means that the graph for cos and the graph for sine, they run smoothly within an interval of 0 to 360 without any disturbance. When I'm saying any disturbance, it means it doesn't have any jumps altogether, unlike the graph of tan. The graph of tan, when we calculate its period, we are going to say 180 over k. And k is the number in front of x. So now, why are we saying 180 on tan and 360 on sine and cos? On tan, remember, for each and every interval of 180, there is a jump. So it means the graph of tan can only run within an interval of 180 without any disturbance. But after 180, if there's a disturbance, then it will start all over from 0 to 180. So that is the difference between the 360 for sine and cos and the 180 for tan. Okay? So now, without any waste of time, let's now learn how to sketch the graph of sine. Remember, the question says sketch the graph of y is equal to sine x, for x is element of 0 to 360. So here we have your restriction. We can call it a restriction or an interval. Remember, they are telling you that the values of x, they must start from 0 and they must end at 360. That is our restriction. And what are we sketching? We have to sketch the graph of y. It's equal to sine x. So with this one, we can see that it doesn't have much effect on it because the value of our a, it's a ghost one, and the value of our k, it's a ghost one. And then it doesn't have the variable of q. So it means our midline, it's y is equal to 0. So now, how do we then start by sketching this graph? Normally, I will try to get the period of the graph first. You must know the period of your graph first. So your period, you know that is 360 over k. Then when you're saying 360 over k, k is the number in front of x, which is ghost 1. So we're going to say 360 divided by 1, which is going to give you 360. So now, that is your period. That is your period for that graph. Then from there, we have to also get what we call critical values. Correct. Critical values, you will always take your period. You take your period and you divide it by 4. always you will take your period and you divide it by 4, and if you say 360 divided by 4, you are going to get 90. And now 90 is your critical values. It means the interval from 0 to 360, they will go with 90, 90, 90, and 90 altogether. So what I mean by that is that whenever you are plotting your critical values on the Cartesian plane, you will start from 0. Then if you say 0 plus 90, you will get 90. If you say 90 plus 90, you will also get another 90. And if you say 90 plus 90, you get 270 and 360. So those are your critical values. It means our critical values, it will be 0, 90, 180, 270, and 360. That's how this graph, it will pass through those points. So now, how do we then sketch our graph? You will go to your calculator, and in your calculator you must have sign of open bracket. When you're saying sign open bracket, where there is x, that's where now you put the bracket. So now, on our calculator, you will just go and press your sign, and you open the bracket and you close the bracket. Then remember, on our equation there, we have the values that we need to substitute, which is the values of what? The values of 0, 90, 180, 270, and 360. So now, how do we then going to do that? You are just going to use your calculator, and then you go and you press 0 because we want the values of sine 0, where our x point is starting. So if you're saying sine 0, you punch in your calculator, you're going to get 0. Then where there is 0, you're going to put your point there. Then from there, you go and inside those bracket, you will now put 90. Then when you put 90 and you're saying equal sign, you will get 1. It means now we are going to say 90 and 1. 90 and 1, that's where now we put our point there. Then you go again to substitute now 180. Remember, it goes with the interval of 90. From 0 to 90, 90 to 180, 180 to 270, and 270 to 360. So now, if now I put 180 and I said equal sign, we are going to get 0. It means now it will go back to 0. Correct. So you can see that it's going to 0. If you substitute 0, 90, you get 1. 180, you get 0. And we still continue to say 270. So if now you substitute your 270 there, then you will get what? You will get negative 1. So now we will get negative 1. 270 and negative 1. So now when you go to substitute the last one, which is 360, we're going to say sine 360. So if you say sine 360, then you get your 0. So now you will have 0 there. Then all those points there, you know this one is 270, 270 and negative 1, and that one it will be 360 and 0. 360 and 0. Correct. So now you will just join your graphs using curves. Correct? Then where it ends at 360. You will join your graph using curves. You must avoid just drawing a graph like this one, you will get wrong. Those things are two different things. They are two different things, so the black one is going to be wrong. You must always use curves. You can't use a straight line, joining those points using a straight line. You must always use curves. Are we together? So that's what you need to do. You must use curves. So now, after drawing your graph, the questions now will come to say, now calculate the period of the graph or determine the period of the graph. So already the period of the graph, we have determined it from our previous slide there. Then now the amplitude, remember the amplitude, we're looking at our midline. From our midline there, where y is equal to 0, the amplitude, we will say from the midline to the turning point, we have only 1 unit. So our amplitude is going to be 1. Then now they can also ask you to determine the domain. The domain, remember, you're talking about x values. And the domain is where the graph is defined. Our graph is defined from 0 to 360. That's where our graph is defined. How to get? Then now, when we have the range we're talking about y values. Now, we're talking about where the graph is defined on the y value. So y values is this line here. That's where we have our y values. So the graph, you can see that it's only defined from -1 up until +1. Below -1, the graph is not defined. And above there, +1, the graph is also not defined. So y will be element of -1 and 1. Correct. So now, or someone can say -1 less than or equal to y less than or equal to 1. Those things, they mean the same thing. They mean the same thing. It depends on how you understand it. They are both correct in terms of writing your range. Okay? So now when we move forward, we go to the graph of now cos. Remember, the shape of cos is different from the shape of sine. And sometimes they will even give you the graph without the equations. So you need to identify the shapes correctly. Then with cos, the question says, sketch the graph of y is equal to cos x. For x is element of 0 to 360. So that is mainly your domain. Your domain. Remember, we said domain is where the graph is defined. So now they are telling you that your graph must be defined from 0 to 360. So we follow the same procedure. We start with our period. Then we want to know what is our period. What is the period for this graph? So for cos, remember, is 360 divided by k. And k is the number in front of x, which is the ghost one there. Then we're going to say 360 divided by 1, which is going to give you 360. So for you to get your critical values, critical values, we said we take your period and divide it by 4 always. Then you get 90. Then it tells you that this graph, it will go in an interval of 90, 90, and 90. So now, in your calculator now, you will have cos and you open the bracket. That's what you will have in your calculator. Remember, we dealt with the one for sine. Now you will have your cos, you open bracket and you close your bracket. That's what you will be having in your calculator. So now you are going to substitute 0 in your calculator. Then you will realize that when you substitute 0, you will get 1. Remember, you have 0 and you will get 1 when we want to sketch the graph of cos. Then now, it says 0, 90, 180, 270, and 360. Those are the values that we are going to use on our axis. So if we substitute 90 now, you will get 0. And if you substitute 180, you will get negative 1. And if you substitute 270, you get 0. And when we substitute 360, you must get 1. So now, also here, when you sketch this graph, it must be careful. It must be careful. Correct. So now, there is your end point. It must end there by 360. So most of our learners will find that they will do something like this. Then it means you are telling us that this graph is continuing here, which is wrong. Correct? Normally, they will tell you that you must show your turning point, your intercept, and the end points. So, your end point, if ever it passes, then you will be penalized for that because you are not answering the questions. So, where the graph ends, you must just put the point to show that this graph is ending there. So, from there now, we will go and look at our amplitude. Amplitude there, we know that A is going to be equal to 1. Then now we go into our domain. We have said domain is where the graph is defined on the x-axis. So it's x-axis element of 0 to 360. So our range now, we're talking about y values. So y is element of -1 and 1, because you can see that our graph is defined from -1 up until 1. That's where our graph is defined on the y-axis. So that's how you determine your domain and range, and also the amplitude. And remember, amplitude, you can also calculate it from there, as long as it's from the midpoint, the midline to the turning point. Okay, so now looking at the graph of tan. The graph of tan, we must sketch it where y is equal to tan x, for which x is element of 0 to 360. How to get? Then now, on this one, what do we do now? We start with its period for tan. But remember, we said tan is going to be 180 divided by k, which is 180 divided by 1, which is 180. Which is 180. That is your period. Remember, k is the number in front of x, and the number in front of x there is goes to 1. So our critical values now, always remember, you will say period, which is 180 divided by 4. Then in this case, we're going to get what? 45. So now, with tan, it means it goes now with an interval of 45. How to get? So now, tan, it means we are going to say 0, 45, plus 45 is 90, plus 45 is 135, plus 45 is 180, up until 360. Then in your calculator now, you're going to have tan of x. Remember, where there is x, you open the bracket. Then you start substituting the values of from 0 to 360 inside your calculator then. Then now, when you're saying tan 0, when you substitute 0, you're going to get 0 then. Then if you say tan 45, you know that tan 45 is equal to 1. Then now you will say tan 90. When you say tan 90, it will show error on your calculator. If now we are looking at tan and you're going to say tan of 90 degrees, it will show that it's an error. Then when it's error, you must know that I am going to have what we call an asymptote. I will have what I call an asymptote, where it's x is equal to 90. That is the equation then of our asymptote. Then from there, when you say tan of 135, you will get negative 1. Then you will have tan 180, you will get 0. And tan 225, you will get 1. Then also, if you look at tan 70, you will also find that our graph there, it will be undefined as well. So now, at 270 now, we are going to also have what we call our asymptote. Correct. So now, the equation is x is equal to 270. Then now, when we're saying tan 315, you will get negative 1, and tan 360, you will get 0. So those are the points for our graph of tan. And also, the graph of tan, it must be in a curves. So you must draw our graph there nicely in terms of this curve, how to get. So here we also have our curve that is going like that. So that's how you will basically see the graph of tan. The graph of tan. Let's draw our curves a little bit nicer there. So you will have something like that when we're drawing our graph of tan. So now, with tan, the things that they are going to ask you is to give us the equations of the asymptote. They will ask you to give the equation of the asymptote. So the equation of the asymptote is x is equal to 90 and x is equal to 270. That is the equation of the asymptote. And avoid just to say 270. If you just write 270, we know that the asymptote is at 270. But the question, when it says the equation of the asymptote, the equation, it must have equal sign. Then the minute you say x is equal to, then that is the equation of the asymptote. Correct. If you only write 270 without saying x is equal to 270, then you will be penalized for that. Okay. So that's how we sketch our graph of tan. Then moving forward now, we're going back to the graph of sine. But now we are having now y is equal to 2 sine x minus 1. And we must sketch it from 0 to 360. We can see now that the value of a now is 2, and now the value of q is negative 1. It means now we are having the effect of a and q. But we still go to the basics. You will still get your period. Remember, the period is going to be 360 divided by k, and k is the number in front of x, which is 1. Then you're going to get the period of 360. Then for you to calculate your critical values, you will say 360 divided by 4. Always you will get 90 if you say 360 divided by 4. So now, in sketching your graph, you will now in your calculator have 2 sine, where there is x, now you put bracket minus 1. So let's see, how are you going to put it in a calculator now? In a calculator, remember, we must have 2 sine x, where there is x, we put bracket minus 1. So you will say 2 sine, then you open, you close bracket, and you say minus 1. That's what you will have in your calculator. Then if you go and punch 0, because we are looking at 0, 90, 180, 270 at 360. If I punch 0 there and I say equal, then you will see that it will be negative 1. Then that's where now we're going to put our negative 1. Correct. Then now you go inside the bracket there, you still substitute 90. We still substitute 90 there. Then if you say equal sign, then you get 1. then 90 and 1. Then now you will have to go and punch your 180, sorry. So if you go and say 180, then you are going to get negative 1 again. So that's where you get your negative 1. Then you go and substitute your 270 now. So if you say the sine 270 minus 1, then you'll get negative 3. So 270 and negative 3. So if you substitute 360, then it will take you to negative 1. So those are the points that you are going to get. And remember, you will join them using nice curves there. You will just join them using nice curves there. So now we have drawn our graph for 2 sine x minus 1. So now we can see that here our midline is what now? It's y is equal to negative 1. It means it moved 1 unit downwards. So it moved 1 unit downwards. But you can see that the period from the midline to the turning point, how many units? It's 1, 2. Not period, sorry, amplitude. Amplitude is going to be 2. That's how you read the graph. That's how you read the graph. Correct. Because sometimes they will just give you a graph, an equation like this. They will give you the equation like this. They said f of x is equal to sine x plus q. Then they give a graph like that. Then they're asking you to say, determine the equation of f of x. It means you must determine the equation of f of x. By determining the equation of f of x, it means we have to read from the graph. And how are we going to read from the graph? Remember we said A, it speaks to the amplitude. Then we are going to look at the amplitude of our graph. The first thing that we need to identify is our midline. Our midline represents the value of what? Of q. So q is going to be negative 1. And A is an amplitude. So the amplitude, you're going to read from, you're going to count from the midline to the turning point, which is 1, 2 units. So your A now is going to be 2. So f of x is going to be 2 sine of x minus 1. That's how you will be determining the equation of f of x. If they draw the graph for you and they ask for the unknown variables that are affecting your function there. So that's how you will do it. So in this case again, you are going to be requested to calculate your range to determine the range. Range in this case is y is element of, now we're looking at the lowest value, which is negative 3, and our turning point there, which is 1. So the range will be y is element of negative 3 to 1. Remember, we are putting square brackets. We are putting square bracket because negative 3 and 1, they are included. Because with 90 is 1, with 270 is negative 3. They are included, those values. So that's how you sketch your graph of sine, having A and P affecting your function there. Looking at the one now for sine x plus 2 is the same as this one. In this case now, our sine, the graph is going to move 2 units upward. It's going to move 2 units upward. And always remember, you will get your period, which is 360 divided by 1, which is going to be 360. Then for you to get your critical values, you're going to say 360 divided by 4, which is going to be 90. I'm doing this so that you know that how do we get our critical values. And remember, critical values, when we're saying divide by 4, this one it's informed by the quadrants that we have. Remember, we have 4 quadrants. So when we're saying divided by 4, it means this graph is going to move from 0 to 90, from 90 to 180, 180 to 270, and 272 to 360. Then you have a complete revolution there. Okay, so now in your calculator, you are going to have sine x plus 2. So that positive 2 is outside the bracket, not inside the bracket. Because if you put it inside the bracket, now you're going to get some funny numbers. So now, if you punch in your calculator and you say sine 0 plus 2, when you're saying sine 0 plus 2, you will find that your graph will start there by 2. Then if you put, you're saying sine 90 plus 2, you will find that this graph now will come to 3. So let's double check that. If now I have the sine, close bracket, plus 2, then now we substitute 90. If we substitute 90, then we get 3, which was correct. Then now if you say 180, when you substitute 180 there, you will get 2. Then 270, you will get 1, and 360, you will get 2 again. So that's where now our graph will look like when we sketch it. Then from there, remember, our mid line is there by 2. Our midline now, y is equal to 2. Then we can start reading from there. The amplitude, we can see that our amplitude is going to be 1. We only have 1 unit there. Then your range now is going to be y is element of 1 and 3. So remember, range will always start with the lowest number and we get to the bigger number. So 1 and 3, that will be your range. So those are the types of questions that they are going to be asking you, and how to sketch your function and looking at the amplitude and the range. Correct. So now, having our graph of cos, now cos, it has the effect of 2 and 1. And we still draw the graph from 0 to 360. So, always advisable to start with a period. Then we'll divide it by 1, which is the ghost one, the value in front of x. Then you will get 360. Then now, when you want your critical values, you'll say 360 divided by 4, which is going to be 90 degrees. Correct? So now, you know that our function now, when we put it in a calculator, it must be 2 cos, where there is x, remember you add it with 1. So in our calculator, in this case, we are going to have 2 cos, open bracket, close bracket, plus 1. So that's what basically you will have in your calculator. Most of the learners, they will make a mistake of saying, maybe they will put whatever and say plus 1 inside the bracket, of which is incorrect if you put it like this one. That 1, it must be always outside the bracket, like this. Then now, if we punch it in a calculator, we are going to get 3. So now, it means we are going to have 3 there. Correct? Then now, when we go and substitute 90, When we go and substitute 90, we are going to get 1. Correct? And we go and substitute 180. Then we have 180 there. Then when we substitute 180, we are going to get -1. So now from -1, we will also get 1 by 270 and 3 by 360 there. Then now you will sketch nicely your graph. You will join those points using curves nicely like that. Correct. So now here we can all agree that our midline is at 1 now, because the graph, it has moved 1 unit upward. Then you will be able to also determine your amplitude. Remember, amplitude, it will be A is equal to 2. Correct. Then now the range for this one is going to be y is element of -1 and 3. -1 and 3. So that's what basically we are doing. Remember, our mid line there, it's 1. Correct? Or the amplitude, you can read from there, which is 2 units. How to get. So that's basically how we are going to sketch our graph, having the effect of A and Q. Are we clear? Okay. Now looking at the graph of tangent. Remember, tangent, for you to get your period is 180 divided by 1, which is going to be 180. And when you get your critical values, you're going to say your period divided by 4, which is going to be 45 degrees. So that's where you are starting. Then now, in your calculator, you know very well that you're going to have tan of x plus 1. That's what you will get. Tan of x plus 1. Then the minute now you substitute, you say tan of 0 plus 1, you are going to get 1. And if you say tan 45 plus 1, you are going to get 2. And always when you're saying tan of 90, you will get your undefined there. And 135, you will get 0. Then 180, you will get 1. And 225, you will get 2. Then 270 there, you will see undefined. Then at 315, you will also get 0. And 360, you will get 1. So now, our graph for tan now, it will look like that. Correct? Then also here, you are going to have a graph that is going like that. So basically, that's how you will see our tan graph. That's how basically you will see our tan graph. Correct. So remember, this graph, it has the asymptote. The asymptote, the equation is x is equal to 90 and x is equal to 270. So now you can see that the mid line for that tan graph is starting at 1. It means it has moved 1 unit upward. Correct. So now, let's now look at the sine graph. But now, with the sine graph, we now have the effect of k. We now have the effect of k. And we're saying now k, it affects our graph. So now, if we want our period in this case, and we're saying 360 divided by k, and we know very well that from our graph, it will be y is equal to a sine of kx plus P plus Q. So now, the value of K is the value in front of X. The value in front of X in this case is 2. So we're going to divide it by 2, then we're going to have 180. So 180 now, this is our period now. 180 is the period for that graph. So you can see that K, it affects the period. It affects the period. So now, if you want now critical values, critical values now we're going to say 180 divided by 4. Remember, you always take the period and you divide it by 4 to get your critical values. So your critical values now in this case is going to be 45 degrees. Then what does it mean? It means now this graph of sine 2x, it goes now with an interval of 45 degrees. So now, when we sketch it in your calculator, you are going to have sine into 2x, then you close the bracket like that. So, where we open the bracket next to 2 there, it's your x value. It means that's why we are going to substitute 0, 45, 90, 135, 180, 270, 225, 270, 315, and 360. So now, in our calculator, in this case, we're going to have sine open bracket 2, you open, close, close again. Then now, inside the bracket there, you are going to start by saying 0. So if you say 0 now, you are still going to get 0. We put 0 there. Then now, when you go and now put 45, because remember, it's going with an interval of 45. The critical values were 0, were 45. It means it's 0, 45, 90, 115, 135, and 180. So now we are looking at 45. If you say 45, then we're going to get not 150, not 450, 45. We delete 0 there, then we get 45. You can see that if you say 45, then you're going to get 1. Correct. Then now, when we go and say 90, when we go and substitute 90 there, what do we get? Let's see. 90, we get 0. So basically, 135, we're going to get -1, and 180, we're going to get 180, we're going to get 0. So already, you can see that from 0 to 180, already, our graph of sine is completing a revolution. We are having a full shape of sine from just 0 to 180. Then now we are not done because we also have to sketch it up until 360. So we are going to continue substitute 225. If we substitute 225, we are still going to get 1, 270, 0, 315, -1, and 360, we're going to get 0. So now this graph will now complete another shape of sine. So now, in this case, you can see that the graph of sine, it has completed 2 full revolution. So now, that's how K affects this particular graph of sine. Then questions will be asked about your range, your domain, and the amplitude altogether. So that's basically how you will draw your graph of sine with the effect of K. So now you can see if we increase the value of K, it means our graph will shrink. It means if we increase the value of K, we're going to see those waves coming close to each other. Then now, let's move forward. Now, we are supposed to now sketch the graph of cos 1 over 2x. For x is element of all real numbers. Remember, always, we start with our period, good people. Our period now is going to be 360 divided by k. Then now we're going to have 360 divided by 1 over 2. Correct? Then now, the period now is going to be what? It's going to be 720. If I'm not mistaken, if you say 360, 360 divided by 1 over 2, then we are going to have 720, of which I'm correct. We are going to have 720 degrees as our period. But now, they said we must sketch it from only 0 to 360. So, our critical values now, we are going to say 720 divided by 4. If now you're saying 720 divided by 4, if you say 720 divided by 4, then what are we going to get? Are we going to get 180? It means now, our interval in this graph, they are going in a form of 180. So now, it means we are going to have 0. From 0, if we're saying plus 180, we get 180. And from 180, we're saying plus 180, we get 360. So that's how they want our graph, with an interval of 180. So now, in your calculator, you will have cos 1 over 2, open bracket, close bracket, and close bracket again. So that's how you are going to get or to punch this type of a graph inside your calculator. Remember, there you have 1 over is cos, open bracket, then 1 over 2, then you close, open, close again. So now that's what you will have. If you substitute 0, you will get 1. Then if you substitute now 180, inside there we're saying 180, then you will get 0. Then when we substitute 360, then we get negative 1. So 360, we're going to get negative 1. So in sketching this graph, remember, it will be a little bit careful like that. Let's put our curve nicely here. Yes, it will be something like that. So that's how now you are going to get our graph of cos. It looks funny. Remember, it didn't complete the full revolution. They said it must end at 360, and our graph is ending at 360. So that's how you are going to sketch this graph. And question will come and say, you must give us the range of this graph. Remember, range, it will be the element of negative 1 and 1, because the graph is having negative 1 and 1. So basically, that's how you will be sketching this. So you see the effect of k, how k can affect our graphs. Okay, now let's look at the one for tan. When we have the graph of tan, remember we're saying our period for tan, it's 180 divided by k, but in this case, k is 2. K is 2. So our period now is going to be 90. So for you to get your critical values, you will take your period and divide it by 4, which is going to give you 2, 2, 22,5, which is going to be 22,5. So now it means this graph of tan, it will go in a range of 22,5, but it must start from 0 to 180. So in this case, we can see that in our calculator, we must have something like that. Then now, what do we do from here? We're going to say tan, open bracket 2, then we open, close, and close again. So that's what we are going to have. So if you say tan 0, you will get 0, then that's where you put it there. Then now, you're saying now tan 90. If we put 90 now, we're going to get, not 90, sorry. It's from 0, after 0, then we get 225. 22,5. That's what we have. Then it's going to give you 1. Correct. So now, let's see if we put 45 now in this case. So if we say tan 45, what are we getting? Tan 45, then we're going to get maths error. Then now that's where you put your asymptote there by 45. So it means if you say tan 67,5, you will get -1, you get 0, you will get 1, and at 135, that's where now you will get your maths error. Then now we're going to have -1 and 180. Then we can simply join our points accordingly. So that's what we are going to get in this graph of tan. So now, the equation of the asymptote now is going to be 45, and the other one is 135. So those are the equation of the asymptotes when we are drawing the graph of tan like that. Okay, that was the effect of K into the graph of sine, the graph of cos, and the graph of tan. So now, let's look at the exam type of questions. How can they ask this type of questions? Remember, in previously, we were only drawing one graph on a set of x's. So now, we are given f of x, which is tan x, and we are also given cos of x, which is g of x. And for x is element of 0 to 360. So the first question will say, draw the sketch graphs of f and g on the same set of x's on the grid provided. Correct. So the first thing that we are going to do is to sketch our graphs. And the second one, it will say, use your graphs to write down the values of x for which f is undefined, f of x multiplied by g of x greater than or less than 0. We are going to calculate the values of x there. So now what we do here, you apply the knowledge that you know now of getting the period for the tan graph. Remember, you divide by 1 because the value in front of x is there is a ghost 1 there. Then you know that your critical values is going to be 180 divided by 4, which is going to be 45 degrees. So that's basically what you're going to do with the graph of tan. And the graph of cos, we're going to have a period. Remember, this one is 360 divided by 1, which is 360. And for you to get your critical values, is 360 divided by 4, which is 90. So that is the interval between, the interval for tan and the interval for cos. And you go in your calculator. For tan, remember you're just going to have your tan x, and for cos, you will just have your cos of x. So now, when you sketch the graph of tan, you are going to see tan 0, you will get 0. Tan 1, you will get, tan 45, you will get 1. Tan 90, it will be your maths error. Then tan 135, negative 1, 0, and 1, 270, it will be undefined. Then we have 315 and 360. If you punch on a calculator, those are the points that you are going to get. Then now, our graph for tan, it will be like that. That's basically what we'll have as the graph for tan. So, yes, that's what you'll have basically for the graph of tan. So, for the graph of cos, you will have 1, 0. No. You will have 1, 0, negative 1, 0, and 1. That's what you will basically have there. So now, with this graph of cos, obviously you will get the graph like that. So that's where now you will have this type of graphs. The graph of cos, the red one, it represents the graph of g of x, and the black one, it represents the graph of f of x. So basically that's what you are going to have there. The two graphs, that's how you sketch them. Then now, remember, that is the first question. So when they mark, you are going to get the correct intercept for the tan, and also you get the correct shape. How to get? When I'm saying intercept is x and y intercept, then you also get another mark for shape and another mark for the end points. End points are very important as well. Then also the one for cos, you will have one mark for the shape, one mark for the intercept, and another mark you can get it for the end points. So now, how do we then determine the following question? 2.1, they say for which values of x, write down the values of x for which f is undefined. Remember, f, we are talking about our graph of f, the black one. So the black one is defined where x is 90 and where x is 270. That's where our graph is defined. So basically for 2.1, you will just say x is equal to 90 and or x is equal to 270. Correct. So now, remember, when this question is asked, where the graph of f is undefined, you might, as a learner, expect to say, no, they want the equation of the asymptote. Now they are asking it in a different form, but basically they are asking for the equation of the asymptote, because the equation of the asymptote, that's where the graph is undefined. So now, that's how you answer this type of a question. So now, 2.2, they are saying now, determine the values of x for which g of x multiplied, f of x multiplied by g of x less than or equal to 0 for x is element of 0 to 360. So, with this type of equation, we always say that the minute they are talking about f of x and g of x, you know that they are representing the y value of f multiplied by the y value of g. When you multiply them, you must get less than or equal to 0. The minute you're saying less than or equal to 0, automatically you are saying the value, it must be negative. Values that are less than 0, they are negative. So, how are we going to interpret this? We are going to interpret this looking at the y values. Y values of what? Y values of x, y values of tan and the y values of cos. We are going to determine this using the y values. But we are looking for the x values. It's like now we are saying the x's are the independent and the y's are the dependent. How to get? So now, how are we going to do this? Remember, for it to be negative, it rather have positive y value of y multiplied by negative y value of g, you are going to get negative number. Or if you say negative y value of f multiplied by positive y value of g, then you are going to get a negative number. So those are the conditions. So now, how do we then get the conditions here? From our graph, this is what you are going to do. This value of y, they are positive. Remember, y's are positive from your midline, and this side are negative. So the minute they cross here, they are going to be negative. I'm talking about the graph of cos. So they're above the x-axis, they are positive. So now you go and look at the one for tan. Tan is positive here. Then it starts to become negative. Then positive. Then negative this side. So now, looking at that, there we'll have your negative. So, looking at that, the y values for the graph of cos, the red one, and the y values of the graph of tan, the black one, you can see that within the first interval, when I'm saying the first interval, I'm talking about from 0 to 90. From 0 to 90. Those values, they are both positive. If you multiply positive, multiply by positive, automatically you will get positive. Correct. Then now, you go to the second one. Next interval is from 90 to 180. From 90 to 180, you have negative multiplied by negative. Remember, the graph of g cos is negative, and also the graph of tan is negative between 90 to 180. So negative multiplied by negative, you will get positive. Then now, from 180 to 270, the graph of tan is positive, and the graph of cos is negative. Then if you say negative multiplied by positive multiplied by negative is negative, then it means this interval, it satisfies our quotient. Correct. Then now, the graph of cos between 270 to 360, it's positive multiplied by negative, which is giving you negative. So we can conclude that from 180 up until 270, that's where the x values are less than 0 when you're saying f of x multiplied by g of x is less than 0. So we get that between the interval of 180 to 360. So how are we going to write our answer? We are going to say 180 less than or we can't say less than or equal to. We say less than or equal to? Yes. It's 182 to 270, then 270 to 360. So one will ask, why are you writing your question like that? Remember, the 270 part is not included. The 270 is not included because the graph of tan at 270 is undefined. Hence, I excluded 270 here and I also excluded 270 there. So that's how you write those two answers there. So now, we're going to look at another graph where now we have sine of x and cos, g of x. And now we are going to sketch these two graphs now. How do we then sketch them? Our sine, if you can look at it, is negative. So it will be 0 minus 90, 180, 270, and 360. So now you can see that our graph for sine, it has the different shape now. But it makes sense because remember, if you go to your calculator and you will say negative sine of, let's say, 90, you are going to get negative 1. So hence, here at 90, we get negative 1. So basically, that's how you will sketch that graph. But the one for cos, it will be the straight graph for cos, which is going to be so now that's one will be the graph for cos. Correct. So that's how you will sketch the two graphs. Remember, this one represents the graph of g of x, which is the one for cos of x, and the green one represents the one for which is negative sine x. So now you answer the very same question here, where now they are saying the y values of f multiplied by the y values of g, they are greater or equal to 0. Automatically, they are talking about positive values of y when you multiply them. So, in this case, we are having this graph being positive, 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 negative, 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 positive, 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 positive. Then the other one, we are having negatives, then positive, 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 positive. Correct. So now, looking at this graph, remember the conditions here, they are as follows. It's either this is negative multiplied by negative, you are going to get positive. Or you have positive multiplied by positive, you are going to get positive. So those are the two conditions, where negative multiplies negative and positive multiplies positive. So now, you can see that from this interval of 0 to 90, you have positive multiplied by negative, which is giving you negative. It means that interval is out. Then we're going to the next interval whereby we're having what? We're having from 90 to 180, where you have negative multiplied by negative, which is giving you positive. It means this interval from 0 to 90 is the correct interval that we are looking for. Then we go to 180 to 270. You can see that here it's positive multiplied by negative, which is negative. And now the last interval is the one that we are looking for as well, because that's where you have positive multiplied by positive, then you can get positive. So the interval that we are looking for is from 0 to 90 to 180 and 270 to 360. They are the two intervals that are answering our question. So how are we going to write our answer? Our answer for that one is going to be, the answer for this one is going to be 90 x and is between 90 and 180, right? Yeah, 90 and 180. Or you will have 270 to 360. That's how you write your final answer for 2.1. So this is the end of the lesson. I hope you have learned more about how the parameters of A, K, and Q affect our graph, and also how to interpret our graphs. Thank you.